Perseverance rover finds intriguing rock that appears to contain traces of Martian life. As it traverses the Martian wasteland, Perseverance has discovered a rock that has caught scientists' attention. It contains features that indicate chemical reactions that chemosynthetic microbes may have once used to extract energy. Scientists remain cautious because further analysis is needed to confirm the discovery. On July 21st, the Perseverance rover was exploring the northern edge of Vallis, an ancient river valley about 400 meters wide that was carved out in the ancient past by water flowing into the Jezero crater. During its journey, it came across an intriguing rock. Analysis by instruments on board the rover showed that the rock had features consistent with the activity of chemosynthetic microbes. The researchers are currently looking for other explanations for the observed features, and emphasize that further analysis will be needed to confirm that they are indeed traces of ancient microbial life. We designed the route for Perseverance to ensure that it reaches areas that could potentially provide interesting scientific samples, said Nicola Fox of NASA. The journey through the ancient riverbed in Vallis paid off. We found something we've never seen before, she added. The discovered rock is about 1 meter by half a meter in size. Its shape resembles an arrowhead. NASA researchers call it Chiava Falls, after the highest waterfall in the Grand Canyon. Repeated scanning of the rock by the rover's Sherlock, scanning habitable environments with Raman and luminescence for organics and chemicals, instruments showed that it contains organic compounds. Although such carbon-based molecules are considered the building blocks of life, they can also be formed by non-biological processes. This is the most enigmatic, complex, and potentially important rock that Perseverance has ever examined, said Ken Farley of Caltech, who is involved in the Perseverance mission. On the one hand, we have the first convincing discovery of organic material, characteristic colored patches indicating chemical reactions that microorganisms could use as a source of energy. We also have clear evidence that water, essential for life, once flowed through this rock. On the other hand, we couldn't tell exactly how the rock formed or how the features on it were created, he added. Large, white veins of calcium sulfate run along the rock. Between them are bands of material whose reddish color suggests the presence of hematite, one of the minerals that gives Mars its characteristic rusty hue. When Perseverance looked more closely at these red areas, it found dozens of irregular, millimeter-wide, creamy white spots, each surrounded by black material, similar to the spots seen on a leopard's body. The Planetary Instrument for X-ray Lithochemistry, PIXL, which Perseverance also carries, determined that these black halos contain both iron and phosphate. These spots are a big surprise, said David Flannery, an astrobiologist and Perseverance science team member from Queensland University of Technology in Australia. On Earth, these types of features in rocks are often associated with the fossil record of microbes living beneath the surface, he added. Such stains on sedimentary terrestrial rocks can occur when chemical reactions involving hematite turn the rock from red to white. These reactions can also release iron and phosphates, which can cause black halos. These reactions can provide energy for microbes, explaining the connection between such features and microbes in terrestrial environments. Scientists believe that if we find signs of life on Mars, it will be similar to early Earth life, optimized for conditions with low or no oxygen. The fossil record of such life on Earth is difficult to study. It consists of layers of fossilized microbial mats sandwiched between layers of sedimentary rock. In one scenario considered by the team, this rock started as mud with organic compounds that eventually cemented into rock over time. Water then flowed through cracks in the rock and deposited mineral deposits that formed the large, white veins of calcium sulfate visible today and led to the stains. While both the organic matter and the spots are of great interest, they aren't the only aspects of the rock that have the science team puzzled. The visible white veins of calcium sulfate are filled with millimeter-sized olivine crystals. The mineral could be related to rocks that formed elsewhere in the valley, possibly from magma crystallization. If so, the team must answer another question: could the olivine and calcium sulfate have formed in the rock at high temperatures and caused an abiotic chemical reaction that created the spots? We've blasted this rock with lasers and X-rays and imaged it from literally every angle possible. From a scientific perspective, Perseverance has nothing more to offer. To fully understand what really happened in the Martian Valley billions of years ago, we'd like to take a sample of the rock back to Earth so it can be studied with powerful instruments available in laboratories on Earth, Farley said. It should be emphasized that the visible features of the rock are not irrefutable evidence of the existence of ancient microbial life on Mars, at least not yet. As NASA's scientists emphasized, further research is necessary to confirm this, and it would be best if it were conducted in Earth's laboratories, because Perseverance has exhausted its research repertoire. This means that the newly discovered rock would have to be brought to Earth. The rover collected samples of the rock, which will now await a spacecraft that may one day arrive and take it to Earth. Perhaps, because the Mars sample return mission is struggling with significant funding problems. However, it may turn out that this discovery will make the mission's problems disappear.